dear students, welcome back to MKG Online Study and E-Learning Platform. This is the video 3 of LGL playlist. Today I am going to tell you something that completely confused me when I first learned Verilog. Reggie, hardware does not think like software. Sounds obvious. But this single sentence is responsible for more confusion than almost any other topic in Verilog. And if you don't understand it, Verilog will always feel weird. And today we are going to fix that forever. Look at this C code. Printf hello, printf world. Easy. What print first? Hello, then world. Because software executes one line after another. Now look at this Verilog code. Assign y equals to a ampersand b. Assign y equals to a or b. Which line executes first? Most beginners answer the first line and that's wrong, very wrong, because something completely different is happening here. The biggest mistake beginners make is treating Verilog like C. They think line 1 runs, then line 2 runs, then line 3 runs. But hardware doesn't read your file from top to bottom and execute it. That's software thinking. Hardware doesn't care about the line numbers. Hardware doesn't care about file order. Hardware only cares about circuits. And circuit exists all at once. Let's understand software first. Imagine you are solving math problem. Problem 1, then problem 2, then problem 3. You cannot solve all three using the same brain at the exact same instant. You go step by step, one after another. Software behaves exactly like that. Sequential execution, one instruction at a time. Every program you write eventually reaches a CPU. And the CPU follows a cycle: fetch, decode, execute, again fetch, decode, execute, again. This cycle repeats billion of times every seconds. That's how software runs, step after step after step. Imagine I give you 100 questions. Can you solve all 100 at exactly the same moment? No, you will solve one, then another, then another. Humans are naturally sequential. Software is naturally sequential. But hardware is about to break that rule completely. Let's revisit our Verilog code. Assign y equals to a and b. Assign z equals to a or b. Most people think first and then or. But wait, why would an OR gate wait for an AND gate? They are completely different circuits. They are not standing in a queue. They are physical structures. And physical structures can exist simultaneously. Two circuits can exist together. This is the moment everything changes. Both gates exist at the same time. The AND gate exists, the OR gate exists right now. Simultaneously, nobody is waiting, nobody is executing, nobody is scheduling instruction. The hardware simply exists. That's huge mindset shift. Imagine one input wire connected to two different circuits. When the signal changes, both circuits see it instantly, not one after another, together. This is called parallelism. And parallelism is the superpower of hardware. AND gate and OR gate respond together. Read this carefully. Everything can happen simultaneously. Software executes sequentially, hardware operates in parallel. That's why hardware can be so incredibly fast. Because many things happen simultaneously, not one after another. This is the one most important ideas in digital system. Imagine a city with three roads, sequential world. Road A moves, road B waits, road C waits. Then road B moves,
Then road C moves. Terrible? Now imagine all road opens operating simultaneously. Much faster, much more efficient. That's parallel hardware. Suppose someone sends a message to a WhatsApp group with 500 members. Do people receive the message one by one? No. Everyone receives it simultaneously. Hardware behaves more like that. One signal, many receivers at the same time. Now, here is another thing that shocked programmers. Hardware has no main. No starting point, no ending point, no first instruction, no last instruction. Hardware simply exists. Always active, always listening, always responding. Think about how different that is from software. At this point, might be wondering if hardware is always active, how do engineers simulate it? Great question. Because simulating billion of transistors sounds impossible. The answer lies in something called events. An event is simply a change. Input changes, output changes, clock changes, reset changes, something changes. And when something changes, the simulator wakes up and reacts. That's the key idea. Let's take an example. Suppose A equals to 0, B equals to 0, output is 0. Nothing interesting happens. Now change from 0 to 1. A changes from 0 to 1. Boom, that's an event. The simulator noticed it, recalculates the output, updates the result, and then goes back to sleep. Here is the secret. A simulator doesn't continuously calculate everything. That would be incredibly slow. Instead, it waits like a security guard. Something happens, nothing happens, nothing happens, nothing happens. Then suddenly something happens, an event occurs, the simulator wakes up, processes the event, and sleeps again. That's event driven simulation. Means if nothing happens, then simulator doesn't calculate anything. If something happens, it wake ups and calculate. That's event driven simulation. Event driven simulation means input changes, simulator wakes up, calculates outputs, return to sleep. Wake up, calculate, sleep. That's it. Simple, elegant, efficient. And this is exactly how modern simulator works. Now, let's connect this to the real world. Why are GPUs so powerful? Why can they process thousands of operations simultaneously? Because GPUs contain massive amount of parallel hardware. Thousands of circuits working together, not one instruction at a time. Parallelism again and again and again. CPU, GPU, FPGA, different hardware. Same idea. CPU, GPU, FPGA, AI accelerator, all of them rely on parallel hardware. Different architecture, same fundamental principle. Let's revisit again our code one final time. Assign y equals to a and b, assign y equals z equals to a or b. Earlier this looked like software. Now you know the truth. Nothing executes, nothing waits. Both circuits exist, both respond, both operate simultaneously. That's hardware thinking. If you remember one thing from today's lecture, remember this. Software executes, hardware responds. Everything else in Verilog becomes easier once this click. Verilog is not describing a sequence of its steps. Verilog is describing structure, connections, circuits, blocks, hardware. You are not writing instruction, you are designing reality. This might be the most important sentence of the entire video. Hardware doesn't run. Hardware exists. Software runs. Hardware exists. And that difference changes everything. But now we have a new mystery. If hardware is always active, how does it remember anything? How does a calculator remember numbers? How does RAM remember data? How does a CPU remember instruction? Where does memory come from? And that brings us to the next chapter: combinational logic, sequential logic, flip-flop, resistor, and the secret behind memory itself. See you in the next lecture. Thanks for watching, and do remember, hardware doesn't run. Software runs, hardware exists. See you in the next lecture, combinational versus sequential logic, the key to memory. If you found this helpful, do like the video, give thumb up, share this video with your friends, hit the bell icon and subscribe the channel. See you in the next video. Let's build the future together.